This is section 10.5, Laws of Logarithms. Now that you've had a little bit of practice working with logarithms and familiarizing yourself with the concept of what a logarithm is, we're going to look at all the different ways that you can use them. How are they helpful to us in our study of algebra? So, the laws of logarithms are found in your book on page 473. If you want to refer back to them later, because I'm going to be writing them kind of quickly in this first part. Let b be the base of a logarithmic function, where b is greater than 0, those are the positive numbers, and b is not equal to 1, because remember that logarithms are exponents, and 1 to any power stays 1. Let capital M and capital N be positive numbers. So there are three laws that we're going to look at. The first one, log base b of m times n equals log base b of m plus log base b of n. So this is showing that there's a relationship between product and addition. We're familiar with that. There have been other rules, other exponent rules that show a relationship between multiplication and addition. So what we're doing here, this works two ways. We can take this condensed logarithm and expand it out into separate parts. So notice that here it starts as log base b. It stays log base b in each part. The base stays the same. It also works the other way. If you have two separate logs that are separated by addition and they have the same base, they can be condensed into one log using multiplication. So multiplication gets expanded using addition, or addition gets condensed using multiplication. There's a relationship there. All right, the next one, law 2, if we have log base b of m divided by n, this can be expanded into log base b of m. And can you guess? We're doing division. What do you think? That's right, we're going to do subtraction. So log base b of m minus log base b of n. So again, the relationship here is between division, or a quotient, and subtraction, or a difference. We've got log base b on the left. It stays the same base when we expand it. So we expand division using subtraction, or it can go the other way. If we have two logs that are separated by subtraction, we can condense them into one log using division. And then we'll talk in a few minutes in the examples about why you might want to do that. Why would you maybe want to split something up, or why would you maybe want to condense something down? All right, one more law. If we have log base b of m being raised to the k power, this k is an exponent on this m. What we can do with exponents is we can actually bring them to the front of the log and make them multiplication. So this becomes k times the log base b of m. So this exponent can be brought out to the front. That's expanding it. If we want to condense it, we would take it up and make it a power on the m. So exponents can move around. They can move from the exponent position to the front of the log, or from the front of the log to the exponent position. All right, so let's look at how this helps us solve some problems. All right, remember there's lots of extra examples in your book besides the ones that I'm putting into the video. I try to use different examples in the video than what are provided in your book, so that way you have some other places that you can look for additional examples. So in this example, we're going to express, it says express in terms of log base 10a and log base 10b. So what we're going to do is they're going to give us a condensed form, something that looks like this side. We're going to expand it out and make it into something that looks like this side. So for the first one, we have log base 10 of a squared root b. Okay. Because this problem is log base 10, when we go to expand this, all of the different pieces that we expand it into are all going to say base 10. So we're going to keep that base through the whole problem. So when we go to separate this, first of all, we need to use a little trick that we learned earlier in this chapter, where we can rewrite something that's in radical form using a rational exponent. So I'm going to rewrite the square root of b. So I have log base 10 of a squared, and then instead of the square root of b, I'm going to rewrite this as b to the 1/2 power. Remember, that's the rule that we learned first thing in the chapter for rewriting radicals. Now, I've got two parts. The relationship here is multiplication. A squared times b to the 1/2. Multiplication. So look at your laws. Which law of exponents talks about multiplication? The first law. Here, two things are being multiplied. Here, two things are going to be multiplied. So we're using this first law. We're going to expand this multiplication using addition. So I'm going to break this one log down into two separate logs using addition. So this is going to become log base 10 of a squared plus log base 10 of b to the 1/2. So using law 1, product, addition. All right, the next thing we have some exponents. All right, which of the laws deals with exponents? Law 3 shows us that if we have an exponent, we can move it to the front of the log. Now, this is something I want you to keep in mind. We have two separate logs now. So the exponent for this a is going to move to the front of this log. The exponent for the b is going to move to the front of its log. So the exponent moves to the front of its own piece. Okay, so we're going to bring this 2 to the front. 2 log base 10 of a plus, we're going to bring this 1/2 to the front. 1/2 log base 10 of b. All right, so the way we expand out log base 10 of a squared square root of b is 2 log base 10 of a plus 1/2 log base 10 of b. Let's try another one. If we have log base 10 of a to the 5th over the square root of b cubed. All right, so a couple things going on here. We have some division, we have a radical sign, and we have some exponents. We need to take this piece by piece. So what I'm going to do first is just like what I did first in example A, I'm going to get rid of the radical sign by rewriting it as a rational exponent. So I'm going to do that for this one as my first step. So this is going to be log base 10 of a to the 5th over b to the 3/2, because it's root 2, the root goes on the bottom, it's raised to the 3rd power, so that goes on the top. So that's not using a law of logarithms, that's just using exponent rules. Now we're going to use one of our laws. So we've got a division problem. Look at your laws. Which law deals with division? Law 2 says that division can be expanded using subtraction. So I'm going to write this out as two separate logs using subtraction. Now, just like with division, subtraction, the order does matter. So when you go to rewrite this, it's important. The piece that's on top comes first in the subtraction, and the piece that's on bottom comes second in the subtraction. It is important that you have those in the right order. So log base 10 of a to the 5th minus log base 10 of b to the 3/2. So I took the division, I expanded it out using subtraction. That's based on law 2. Again, it started as a base 10 problem, and it's going to stay a base 10 problem all the way through. All right, one more thing we have to do. We have exponents. It's not fully expanded until we treat the exponents, so we're going to move those to the front of their individual parts. So this is going to become 5 log base 10 of a minus 3/2 log base 10 of b. So fully expanded, this is what we have. All right, now let's go the other way. If we can expand a logarithm, we can also condense multiple logarithms down into one part. So that's going to be our next example. Expressed as a single logarithm. All right, express as a single logarithm. So here we're going to be using those same three laws, but we're going to be condensing. So if we have 3 log base 6 of m minus log base 6 of n over 2. All right, so first of all, these don't even look like they're the same kind of thing because this one is not a fraction, this one is a fraction. So what I want you to remember here is if we have x over 2, that's the same thing as 1/2 times x, okay? If we have something being divided by 2, it's the same thing as multiplying that thing by 1/2. That's what's happening here. So keeping that in mind, I'm going to rewrite this second part. So we have 3 log base 6 of m minus 1/2 log base 6 of n. So instead of writing it over 2, I multiplied it by 1/2. It's the same thing. Okay? Now we're going to be able to use our laws. So first, we've got these numbers that are out in front of the log. Do you know where those go? Law 3 tells us that these numbers that are in front become exponents. So they're going to move into the exponent position. So I'm going to have log base 6 of m cubed minus log base 6 of n to the 1/2. So that's law 3 is that exponents condense in this way. Then we have subtraction. Look at your laws. Which law has to do with subtraction? Law 2 says that subtraction goes with division. So I'm going to condense these two logs into one log. That means I'm only going to write log one time. Condensing 2 into 1. So I'm only going to write log one time. It's going to stay base 6. And then I'm going to condense what was subtraction into division. So this is going to become m cubed over n to the 1/2. All right, so I condensed from 2 logs down into 1 log. They were separated by subtraction. Now they become a division problem. All right, one more thing you can do here that you'll see that your textbook will do. Your textbook will then take this one step further and rewrite this rational exponent into radical form. So your textbook will take this one step further and make it m cubed over the square root of n. Because remember, n to the 1/2 power and the square root of n mean the same thing. They're interchangeable. One other thing I should have mentioned earlier, if you're curious about where these laws of logarithms come from, There are proofs in your book that explain how they came up with these laws. This is not just Mrs. Fuller making up some fun rules to do with logarithms. There are proofs that support this if you're curious to look at those. All right, let's try condensing a couple more. There's lots of little tricks that come up in these. You have to kind of be a little bit of a mental gymnast. You have to be willing to play around with things, try things one way. If it doesn't quite go the way you're expecting, go back and try it a different way. It's easy to want to give up on these, and I would encourage you not to do that. If you're not sure what to do, remember way back at the beginning of this chapter, I told you if you're not sure what to do, you can always try rewriting something in a different form. So if you get stuck, think, how could I rewrite this? All right, so we're going to do this one. We've got 4 log of m minus log n. This one's actually a little bit simpler than our first example. We've got this number out in the front as a coefficient. Remember, our coefficients become exponents. So this is going to be log of m to the 4th minus log of n. Then we've got 2 logs that are separated by subtraction. If they're separated by subtraction, they are going to condense using division. So 2 logs condensed into 1. I'm only going to write log one time. M to the 4th over n. Now, something you might have noticed on this problem is that there is not a base written in. There's not a little base right here or right here. When they don't write in the base, it's understood to be base 10. Base 10 is called the common log. So anytime you don't see a base specified, it's understood to be base 10. And your calculator is set up to calculate in base 10. All right, let's try one more of these that's got a little trick in it that we haven't seen yet. If we have log base 2 of a plus 1 plus log base 2 of b all over 2. All right, so first you're going to look at this and think, what is happening? We haven't done one like this yet. Why did she give us this problem? All right, don't go down that rabbit trail. Think of what you can do to rewrite something. This 1 is the trick I wanted to show you here. Earlier in the chapter, we learned about the identity. So remember that log base 2 of something, we want it to equal, let's see how I want to do this. Log base 2 of something, we want it to equal 1. Okay, I want to know what goes in this blank right here. If I want log base 2 of something to equal 1, well, if we rewrite it in exponential power, the base stays the base and the other split places. 2 to the 1st equals our mystery number. Well, we know what that is. 2 to the 1st is just 2. So according to the identity, log base 2 of 2 equals 1. That's true for any log. So log base 3 of 3 would equal 1. Log base 9 of 9 would equal 1. Log base a of a would equal 1. So anytime you have a 1 sneaking in, you just rewrite it log base, whatever base your problem is, and then make it of that same number. So that's how we're going to treat the 1. Over here, we saw this trick earlier. If it's divided by 2, remember it's the same thing as being multiplied by 1/2. So let's rewrite this. We've got log base 2 of a plus log base 2 of 2, because we know that log base 2 of 2 actually equals 1, plus 1/2 log base 2 of b. Instead of dividing it by 2, I'm going to multiply it by 1/2. All right, so now I've got 3 separate logs. They're all base 2. They're all being added. So according to our laws for logarithms, if we want to condense multiple logs that are connected by addition, we're going to condense them into one log using multiplication. So I'm only going to write the log one time, and then I'm going to multiply all the parts. So I have a, and then I'm going to multiply that by 2. And then here we need to move up this 1/2 as an exponent, and then we're going to multiply it by b to the 1/2. So I did 2 steps there. I brought up the exponent, and then I condensed the logs. All right, so we have a times 2 times b to the 1/2. Let's clean that up a little bit. B to the 1/2, remember, is the same thing as the square root of b. And then instead of a2, we usually write 2a. So this becomes log base 2 of 2a root b. We had 3 separate logs. We condensed them down to 1 log. All right. A couple more things to show you. This lesson is a little bit long, but this assignments are broken up over 3 days. So I would recommend if you watch the lesson all the way through and then come back and just find the part that you need that goes with the problems that are assigned for the day that you're working on. So you're not going to do all of this in one assignment. It's going to be broken up over several assignments. All right, the next thing we can do is we can compute numerical values of logarithms using our exponent rules. So for example, 3, given that log base 2 of 3 is equivalent to 1.585 and log base 2 of 5 is equivalent to 2.322, find the following. All right, so they're giving us the decimal values for the log base 2 of 3 and the log base 2 of 5. We're going to have to use this information to solve the following. So if we have log base 2 of 81, well, they didn't give us 81. They gave us 3 and they gave us 5. So that's what we have to work with. So what we have to think of is how can we rewrite 81 using 3 or 5? Hopefully the 81 is making you think of 9. 81 is 9 squared, and then we know that 3 squared equals 9. So that means that 81 is 3 to the 4th. So first I'm going to rewrite the 81 as 3 to the 4th because 81 equals 3 to the 4th. Then I'm going to use law 3, exponents move to the front. So we have 4 log base 2 of 3. This is a product, 4 times this. Well, now we've got log base 2 of 3. Up here, that's defined for us, log base 2 of 3. So now I can substitute that in. I have 4 times 1.585. Now it's just a calculator problem. Multiply that out, you get 6.34. So they gave me 81, but I only had 3 and 5 to work with. So I had to rewrite the 81 as something to do with 3 and or 5 so that I could use the values that they gave me to solve. Let's try a couple more. If we have log base 2 of 15. All right, so we don't have 15, but we have 3 and 5. Well, what's a relationship between 3 and 5 that could give us 15? Multiplication. So log base 2 of 15 can be rewritten as log base 2 of 3 times 5. All right, we know from rule 1 that things that are being multiplied can be expanded using addition. So I'm going to expand this and make it log base 2 of 3 plus log base 2 of 5. That's law 1. Now log base 2 of 3 is a known quantity, 1.585. Log base 2 of 5 is another known quantity, 2.322. So we had to get creative. what they wanted us to solve, we had to use what we had to build that number. All right, then we used our logarithm rules. If we add this together, 3.907. Notice at no point did I just type into my calculator log of 15 or log base 2 of 15. This is not a calculator problem in that way. Your calculator is set up to do base 10. This is not base 10. So we need a workaround. This is our workaround. All right, let's try one more. If we have log base 2 of 6. Now, this one is not as obvious. That's why I picked this one. You have to think a little deeper on this one. We still only have 3 and 5 to work with. If I have to use the 3 or the 5, I'm going to go with the 3. I know that 6 can be rewritten as 2 times 3. So let's see if there's anything we can do with that. We don't know log base 2 of 2 in this way, but if you remember back to a few minutes ago, I talked about this. Log base 2 of 2 plus log base 2 of 3. These are a product. They can be expanded using addition. And then we talked in a previous example in this lesson, we talked about this is a special kind of logarithm. It's called an identity. Log base 2 of 2 equals 1. Because log base 2 of itself will always equal 1. Log base 3 of 3 will equal 1. Log base 7 of 7 will equal 1. Remember that. Watch for it in a problem. Watch for ways to use it. And then log base 2 of 3 they gave us. That's going to be 1.585. So now we just have to add that together, 2.585. You have to think about these. They are not always going to be obvious and jump off the page at you. You have to think about how you can rewrite this. How can you use what's given to rewrite this? There are a couple of you in this class that I'm thinking of in particular. Have fun with this. You guys are so smart. Use those smart brains that you have. Take the time to sit here and play around with these numbers a little bit and get the answers that you need. All right, if you're getting stuck on these, be sure to check out more examples on page 474, example 4. There are several parts to this one where they show a lot more of these types of examples. If you're getting stuck, please go through and look at those examples in detail. Look at them step by step. Maybe even copy them down step by step and think to yourself, okay, what's happening from this step to this step? What changed? What's happening from this step to this step? How did it change? Really spend time. Don't just look at the example and say, I don't get it. Try to work through the example with the steps that are written out in front of you. All right, we're getting close to the end. We're almost there. Told you this was a long one. All right, the last thing I want to show you how to do is that you can use the laws of logarithms to solve equations. So in your book on page 475, it mentions that because the logarithm of a variable expression is defined only if the expression is positive, be sure to check the answers that you obtain. I will talk about that, what that means when we get an answer. All right, so let's do a couple of these. We're going to solve. Let me get a new piece of paper. All right, here we go. Log base 5 of x equals 3 log base 5 of 2 plus log base 5 of 7. Okay. Our goal here is that we want to condense the logs wherever we can. So on the left, we only have 1 log. That's good. We want to keep that as 1 log. On the right, we have 2 separate logs. We want to condense this into 1 log. So I'm going to use my rules, my laws 1 through 3. So rule 3 says that I can bring this coefficient up to the exponent position. So log base 5 of x equals log base 5 of 2 cubed plus log base 5 of 7. Okay. All right, I know that 2 cubed is 8, so I can do that in just a second. Now we have 2 logs separated by addition. According to Law 1, addition condenses using multiplication. So I'm going to take 2 separate logs, write them as one log using multiplication. So log base 5 of x equals log base 5 of 2 cubed, which is 8, times 7. So I condense those two into 1 using multiplication. All right, log base 5 of x equals log base 5 of 56, because we know that 8 times 7 is 56. And now it's kind of a logic thing. If the log base 5 of x has to equal the log base 5 of 56, then x must have to equal 56. So basically, once you get it down to one log, you can drop the logs and just bring down the parts that are, I need to look up the vocabulary word for that, sorry guys. Bring down these parts, the arguments maybe, and set them equal to each other. All right, when it talks about positive values, you always want to take this back to the original and check it. We cannot take the log of a negative number. So if I plug in this 56 right here, it has to be positive, log base 5 of a positive thing in order for it to be true. So log base 5 of 56 has to be positive wherever that x is. Okay, last example. Again, when you come back to solve these problems, find the part of the video that relates to the set of problems that you're doing for that day. So watch the whole video through one time, kind of get a good overview of what's happening, and then when you get ready to solve the homework problems, come back to that section of the video and rewatch that section of the video. All right, last one. Log base 7 of x plus 1 plus log base 7 of x minus 5 equals 1. All right, this one's a little bit different than example A, but I'm going to follow the same idea. I've got 2 logs. I want to condense them into one log. Right now, they're separated by addition. Addition condenses using multiplication. So this becomes log base 7 of x plus 1 times x minus 5 equals 1. So 2 logs condensing into 1 using multiplication. All right, now I don't have a log over here on the other side. So in example A, I had log to log, so I could drop the logs. In example B, I don't have a log compared to a log. So for this one, I'm going to rewrite it in exponential form. So you have to remember how that goes from earlier in the chapter. The base stays the base and the others switch place. So the 7 is still the base. And then this part is going to switch places with this part. So 7 to the first equals x plus 1 times x minus 5. Okay, 7 to the first is just 7. And now here we're just in comfortable algebra space. We need to FOIL. So we've got x squared minus 5x plus 1x minus 5. Let's combine our like terms. Negative 5x plus x is negative 4x. Then if we want to solve it, we need to set it equal to 0. So we're going to subtract 7. 0 equals x squared minus 4x minus 12. Then we're looking for factors of negative 12. So 1 and 12, 2 and 6, 3 and 4. We want something that could add up to a negative 4. So if I have negative 6 and positive 2, so I'm going to have x minus 6, x plus 2, set each factor equal to 0. So I get x equals 6 and x equals negative 2. All right. Now, here's where we need to do a check. We need to take each solution individually and see if it's feasible up here in the original. So if I take a 6, 6 plus 1 is 7. That's positive. I'm really right now just testing to see if this is positive. So that's going to be positive. Over here, 6 minus 5 is 1, and that's positive. Positive, positive, that one's okay. So that's a solution. Check the negative 2. Negative 2 plus 1 is negative 1. So that one is not going to work. Negative 2 minus 5 is negative 7. So it doubly doesn't work. It only has to be canceled out once. But we cannot take the log of a negative number. So if you plug it back in and you get a negative value in this position, you're not going to be able to use that solution. So the solution for this one is just x equals 6. All right, we covered a lot of material in this lesson. Again, please come back and refer to the videos. Just because you watched it once doesn't mean that you've got it mastered. So come back, watch it again, find the part that corresponds with whatever it is you're trying to do for the assignment for that day. And then if you have any questions, you're always free to email me. I'll also do some searching online. Maybe I can find some more Khan Academy videos that match up with this material and post those for you on our Google Classroom. In the meantime, remember guys, there's strength in numbers.